We're going to take a look now at areas under any normal curve. Now in that last section, that last unit, we took a look at curves that were z-curves. These were standard normal curves. These are curves that have already been converted to z-values. The high point was 0, and we did things like this. What was maybe the area between 1.7 and 2, say 1.73 and 2.51, all right? So we wanted to find the probability of landing in that interval. A randomly picked value of z lands in that interval, and we did it by measuring that area right there. And we found that area using a table. Now, we're going to extend this to using x values. So what we're going to do is, if we're given x scores, now sometimes we'll call those raw scores. So if we're given x scores, what we're going to do is convert to z-scores. And then what we'll have is use a table. All right, but really, we're going to do this only once. And then what we're really going to do is how everybody does it for real. We're not going to use the table. We're going to use our calculator. So we're going to bypass this standard curve altogether and just use the calculator. But I want to show you how to do it at least once in case you may see it again. Here's an example out of the book. I think it's number 26. It says that porphyrin is a pigment in blood protoplasm and other body fluids that is significant in body energy and storage. Now let x be a random variable that represents the number of milligrams of porphyrin per deciliter of blood. Now, in healthy adults, x is approximately normally distributed. Okay, let's draw this right away. All right, so what we know so far is that we have a normal distribution of porphyrin, and we know that, what do we know here? We know that it's normally distributed, so I'll draw a normal curve. I know that the mean is 38, so the high point here is 38. And what do we know about the standard deviation? The standard deviation is 12, so I'm just going to write this down here so I have it. Mu is equal to 38, and sigma is equal to 12. Now, here's the questions. Part A, what's the probability, let's just do part A here. What's the probability that, what is the probability that x, now x is what? That's a random variable that represents the number of milligrams of porphyrin per deciliter of blood. Okay, so how much porphyrin do you have in your blood? What is the probability that it's less than 60? All right, so we're going to come over to our picture. We're in x's, so we'll draw a 60 here. And we want to know what's the probability that we're less than 60. All right, so what's the probability of drawing some blood, measuring the porphyrin level, and getting a value down here in this interval here, right? Less than 60. All right, that's what we want to know. We can do this, we know, by measuring this area right above 60, right? So we're going to measure this area. Now, here's the way that we did it in the last section. We're going to convert to z using z equals x minus mu over sigma. So now we'll get z is equal to x. Now, we need to convert this x value here to a z-score, right? So our x is 60. So we're going to get 60 minus the mean, which is 38, all over the standard deviation, which was 12. Okay, so this is all over 12. So this gives us that z is equal to 60 minus 38 is 22 divided by 12. So z is equal to 1 point. Now we're going to use a table. the table only goes out to two values. So I'm getting, 1.8333 dot, dot, dot. So how about if we just use z equals 1.83? So I start here with the x curve. I convert it to a z curve so that I can use the table. So now I'm going to draw the z curve. High point, remember, is 0. And now this number right here, this 60, that corresponds to the 1.83. All right, so this is now 1.83, and we're looking for this area. Right, the pictures kind of look the same, but in the top one we're in x's, the bottom one we're in z's. Now remember how the table reads. The table reads like this. It always reads from negative infinity to the right, and that's exactly what we have. So in the table, you need to look up 1.83. Now, just for a minute, I'm going to switch to that table. Here's the table. So I'm going to look up 1.8. All right, so follow it down. There's 1.8. Over to the 3, right? 1.8, and then the second decimal is across the top. So 1.80123. So I'm getting 9664. And remember, it reads the area is from the very left all the way up to your z value. So 1.83 was that 0.9664. Now let me go back to our problem. So that 1.83, this area turns out to be, let's see if I can actually draw it, 0.9664. All right, so and then we've got it. So now what we can say is this. The probability that, what was our problem? That x is, say, less than or equal to 60, that is 0.9664. All right, so I started with an x value. I made a conversion and to z values, and then I was able to use the table. But these tables are cumbersome. They take a long time to do, and I don't really need to do this now that I have some technology. So here's this problem again. Let's do it using some technology. Now here's part A. All right, so I'm going to do part A. What we want is the probability that x is less than 60. All right, so I'm always going to draw a picture. I just like to draw pictures so I know exactly what it is I'm looking for. So here's a normal curve. I know it's normal because the problem says so. The mean, the high point is 38. We're over here at 60. And I want to know what's the probability that we're less than 60. So if you choose a random value of x, what's the probability that you're down in that interval? Okay, so we're going to measure that area. All right, so where does this area go? This area goes from negative infinity all the way up to 60. So now do something like we did in the binomial distribution. We used our binom PDF, binom CDF, remember that? So here's where you're going to go on your calculator. All right, the first thing you're going to do is you're going to press, see if I can get it to right here. You're going to press second. And where's the second key? Right there. Okay, I don't consider that a row. So row 1, column 1. You press second, and then you come down and you press vars. All right, you press the vars key. So row 3, column 4. So you press second, then you press vars for variables, and right on top of that is distribution. So try that. You get second distribution, and then you get a menu. Now in your menu, number 1 is normal PDF. I don't think we're ever going to use that. The one that we want to use is normal CDF because we're accumulating an area, right? We're accumulating all this area right here. All right, so choose number 2. So you're going to type in number 2 or scroll down and press enter. All right, so you select number 2 and press enter. And what comes up, do it at the top here. What comes up, at the very top it says normal CDF to remind you which one you're using. And then, at least my calculator says lower. All right, so what is the lower? Now, in this case, the lower, look at this. This goes to negative infinity. We need a way of telling the calculator negative infinity, all right? So this is going to be negative infinity. How are we going to tell the calculator to do that? There's no infinity sign on this. So here's how to do this. What we're going to type in is E negative 99. Now that means something like this. 10 to the negative 99th. Very small, right? This is really like negative infinity. So how do you get this? How do you get this E negative 99? All right, so here's what you do. You press this key right here. All right, so let me be sure. You see that comma key. Now the comma is right above the 7. It doesn't show up too well on this. How about that? Make it a little bit bigger just for a minute. All right, so you're going to look for that comma key, and right above it, it says EE. So how do you get there? You press second, and then the comma. And get that back down here. Okay, so second and comma. So the way you're going to do it is you're going to press second, and then actually it's what? It's the 7 key. No, it's not the 7 key. It's the comma key, but it says EE right here. But when you press it, you just get one single E. So you just get one single E. Now, you need negative 99. All right, so, well, let's just run through this again. How do you get that E? How do you get that E? You press second, and then above the comma it says EE. And then that single E comes out on your calculator. Now you get negative 99. So you need the negative key. So be careful. It's not minus. It's not this. Nope. It's this. Negative key. All right. So how do you get it? You just press that key right there. All right. So now you press this key. That's the negative key. And then you get a negative sign. And then put 99. Now press enter. So you've got lower. Then the next thing that comes up is upper. Now the upper, that's the 60. That is the 60 that we're going for. All right, that's our upper limit. So we're going from negative infinity to 60. Press enter. And then it's asking you for mu and sigma. So mu, now in our problem, mu is 38. Press enter. Sigma is 12, right? So you always have to press enter to actually make it happen. Okay, and then you come down here and it says paste again. All right, so go ahead and press, it doesn't say it, just press paste. Okay, so you come down, I'll do it on mine, enter. Now here's what I get on my calculator. It says, it's supposed to say this, but we can't read it all. It says normal CDF, then it says E negative 99 to 60, 38, 12, and close. All right, that's what my calculator shows. Now what's really only showing up is just from here. All right, that's all it shows because the screen's just not big enough. Okay, now press enter. So press enter. So paste it on the screen, press enter. Now here's what I'm getting. I'm getting 0.9658525 ... Okay, let's round to 4 decimal places. So I'm going to round right to here. Now, that's a 5. Round to an even number, right? Round to an even digit. 8's already even, so I'm not going to round up to 9. I'm just going to leave it as 0.9658. Okay, there we go. Now, so what I can conclude then is that the probability of getting a sample with a porphyrin level that is strictly less than 60, that's equal to 0.9658. Now in part B, they're asking us what's the probability that the porphyrin level is greater than 16. All right, so probability that x is greater than 16, I'm going to draw a little picture. I like these because they tell me which way I'm going. All right, so I got a normal curve. The high point is our mean, 38, and we want to be greater than 16. Now this is 38, so 16, that's 38. 16 must be over here, right? So I'm just going to write a 16 out here. And what's the probability that we randomly choose randomly choose somebody, test their blood, and the porphyrin level comes out to be greater than 16, somewhere in this interval, right? So what we're going to do is get a measure of that area. So what we're going to type in here is, right, we're going to go to second, VAERS, because that's where distribution is. And then we're going to select number 2. Item number 2. We're going to get normal CDF and press enter. Okay, so press enter. Now what it's asking for is this. It's asking for the lower bound. Now we are going from 16. That's our lower. So we're going to type in a 16. And then it wants the upper, right? So press enter, type in 16, press enter. Now the upper. Now look at what is happening here. This is going off to infinity. Now here's how we say infinities with that E again. So we're going to get E and then just 99. Now here's where you get that. Where do you get that E? The E is really EE, and it's on blue above the comma. So you have to press second and then comma. All right. So what you're going to do here is, to get this, you're going to press second, second, and then that comma key, because that's where the EE is. But when you press it, you just get one E. And then just type in 99. That's the way of saying plus infinity. It's like 10 to the 99th. It's not infinity, of course, but it's a really big number. All right, so now it wants to know the mean. Now that may be left in there from the last time we did this. This is 38, sigma is 12, and then you're going to go to paste. All right, so you get those numbers in, you go to paste, and once again you're going to get, not that you can see it all, but you get normal CDF on your screen, and it goes from E. Well, you don't get E here, right? What do you get? Let me get that right. What's our lower bound? Our lower bound is 16, so you're going to get 16. Then you get that E99, lower bound, upper bound. Then you get the mean, 38, the standard deviation, 12. Now, you can't see it all, right, because the screen's just not big enough. But you press enter, and then you get 0.96663 ... If I round to 4 decimal places, that's a 2, so I'm just going to cut it off here. So I'm going to get this. The probability now that x is greater than 16 is 0.9666. All right, so if you randomly select a person, check their blood for porphyrin level, the probability that it will be greater than 16 is 0.9666, or about, what is this? About 96.7% of the population of all people will have porphyrin levels above 16. Now, part C, they're asking us, what's the probability that the porphyrin level is between 16 and 60? All right, so I wrote it in English. Now I'm going to write it like this. What's the probability that 16 less than x less than 60? I'll draw my picture. These are x's. Now, we're not doing any of that converting to z, because you have to use a table for that. All right, the high point is 38. 16 is over here on the left. 60 is over here on the right. And we want to choose just choose some person at random, test their blood. What's the probability that that person's porphyrin level is between 16 and 16? Or for that matter, what percent of the population has porphyrin levels in that range, 16 to 60? Well, we're going to get this by measuring this area, right? The area between over that interval and under the curve. So what are we going to do? Well, same thing we've been doing. You're going to press second, vars, right? Vars, you get distribution. And then you're going to go get number 2, which is normal CDF. And then what do you get? You get lower. And what's our lower bound here? 16. What's the upper bound? 60. Mu, 38. Sigma, 12. And then paste. And when you paste, you get normal CDF. Now I can only see the F, but then I'm going from 16 to 60 with a mean of 38, standard deviation of 12, and when I press enter, I get 0.93324 ... and so on. Round off to 4 places. That's a 4, that's below 5, so I'm going to get 0.9332. So I'm going to claim now that the probability that a person's porphyrin level is between 16 and 60 is 0.9332. Or it's another way of saying is that there's a 93.3% chance this person's porphyrin level will be between 16 and 60. Or you could surmise that about 93% of the population has porphyrin levels between 16 and 60. And now in part D, we want this. What's the probability that porphyrin level X is greater than 60? Okay, well, I'm going to draw a curve. It helps me to know where I'm going, my lower and upper bounds. High point is 38. 60 is out here. And we want to be greater than 60. So we want to know what's the probability of landing in that interval there. All right, so we're going to find that area. So what are you going to do? You're going to go get number 2, right, which is normal CDF. So second vars, select normal CDF, all right, and it's asking you for, okay, I'll do it too here, normal CDF. It's asking you for the lower bound. Now the lower bound is 60. What's the upper bound? Okay, 60. The upper bound. Now the upper bound, see what we're doing? We're going off to infinity, so remember how to do that infinity? To get the infinity, you're going to do the E99. Now I got to fix that 60. It looks like a 66. All right, so E99. And how do you get that E? It's second. And then right above the comma, there's that EE. EE, but you press it and you only get one E. All right, so this is the way of saying positive infinity. Now I've already got the 38 and the 12 in from the last problem, so I'm just going to scroll down now to paste, right? So highlight, paste, press enter, and then I'm getting this, normal CDF, although I can only see the F. I'm going from 60 to positive infinity, E99, 10 to the 99th, mean of 38, standard deviation of 12, and then when I press enter, I'm getting this. Oh, I got a 0. Well, I didn't just get 0. Let me look at the whole thing. I got 0.033376. So if I round off to 4 digits, that's a 7 bigger than 5. I'm going to round up to 0.0334. So I'm going to say then, I'm going to claim that the probability of getting a value, a porphyrin level greater than 60 is 0.0334. Now that means that, what, there's about a 3.34% chance of getting that, or 3.34% of the population is greater than 60. Or I could say this. Now, 0.0334, tenths, hundredths, thousandths, 10,000. So if I write as a fraction 3, 3, 4, right? I don't need the leading zero. That means if we examine 10,000 people, how many would we expect to have porphyrin levels above 60? 334. So what it means is that we expect about 334 people out of 10,000 to have porphyrin levels above 60. So what if we actually did this? We actually test the blood of 10,000 people. And I'd be surprised if we got exactly 334, but we're going to get around 334, right? If I get 325, that's probably okay. What if I got 350? Maybe that's okay. What if I got 400 or 500? What if we got 700? We're expecting 334 out of 10,000, and we saw, say, 700. That would make you suspicious. So then we have to run a test. So then we'll do that kind of thing a little later on in the text.